Hello folks. So in this small tutorial, we will take a practical example of DBSCAN method where we have our two-dimensional data, x-axis and y-axis values are given here in these data points. So 13 data points we have, and we want to cluster this using DBSCAN clustering method. So first we need to calculate the distance between each and every point. So for that, I have written a function in R. So here we have taken the points x and y into vectors, x and y vectors, and then we converted those x and y into an array like this. If you just run this, you will have an array like this. So these are the original points that you have. Then I have written a function, small function, to compute the Euclidean distance between any two points P1 and P2, and we know this is square root of the P1 1, this is the x-axis of P1 minus P2 1, that is y x-axis of P2 square, plus the y-axis of P1 minus y-axis of P2 square. And finally, we take a square root of that, and that will be the Euclidean distance between P1 and P2. So, if you want to find out Euclidean distance between the first point and all the other points, we will take a for loop and we will just print the Euclidean distance between, this is the first point, a1 1, and this is the ith point for all I from 1 to 13. If you just first need to run this one, and then you need to run the for loop. So here we go, we have the distances between the first point and all the other points. So the first point, the distance with itself is 0, and these are the distance in all the remaining 12 points. This will be like this. This is distance from the first point, which is 1 comma 2. Now let us choose epsilon is equal to 0.6 and mean points is equal to 4. You are already known to these terms. So any point which has distance lesser than 0.6, less or is equal to 0.6, will be in the epsilon region or the epsilon boundary of point 1 comma 2. Here we have, these are the points which have lesser distance, like here we have 0.53 and we have 0.5. These are the 2 points, which is 1.2 comma 2.5 and 1 comma 2.5. These are the points which comes like here. These are the points which comes within 0.6 region of 0.6. This is the epsilon 0.6 region of the point 1 comma 2. So this is the point 1 comma 2, right? So in this way, how many points we get? 2 points only. Like this, for all the remaining 12 points, we will find the neighborhood point. For that, we need to go to this R code and just need to change here. For the second point, I will just change here this one. I will just change here A2 like this. Now just run it and we'll have, these are the points. So you can find out 0.5 and 0.53. So you have 2 points. Which are these 2 points? Just find out here, 2.5 comma 4 and 2.8 comma 4.5. Like this, I will continue with all the points. Now, so this is the second step. The third step is to find out the cluster. So cluster can only be formed around a core object. So see, this is not a core object as this does not contain minimum number of points, which is 4. So this cannot be any core object. Now this can be a core object as it contains 1, 2, 3, 4 points, which is equal to the minimum number of points. So this, here we can start a cluster. Now what we look forward to is, can we move on to another core point from these neighborhood points. So the question is basically, is there any core point in this neighborhood points, in the set of neighborhood points? So let me find out 3 comma 4 here it is not a core point, 2.5 comma 4 here it is also not a core point, 3 comma 5 it's also not a core point, 2.5 comma 4.5 it is also not a core point. So we cannot go to any other density connected point. Remember the density connected point must also be a core point. So we need to stop here. The cluster 1 will stop here. Next point we visit 2.5 comma 4.5 which is not a core point. So we cannot form a cluster around it. Next point 1.2 comma 2.5 here also we got 4 points. So this can be a 4 point and we can start to build a cluster around it. So this will be my second cluster. And now the next question will be, is there any point which also leads to a core point? So see here 1 comma 2 which is not a core point, 1.5 comma 2.5 it's not a core point, 1 comma 3 it is also not a core point, 1 comma 2.5. Now see this one. So here we have four number of neighborhood points. So this can be a 4 point. So we will merge this with this and we'll call this as a single cluster. Now, again, we will ask whether we can move on to any other 4 point from these neighborhood points, and you can check that we cannot go to any other density connected point. So we need to stop here. So cluster 2 is done. And like this, we will visit all the remaining point. 1 comma 3 is not a 4 point. 1 comma 5, 5 comma 6, and 4 comma 3. These are the points does not have any neighborhood point. So this is the second step. Now, as we have done this, we now can find out which are the border point and which are the cluster points, core points. So this is the border point, a point which is part of any core cluster, core neighborhood of any core point, but is not a core point itself. And these three, in fact, are core points. Remaining points are border points. But then we have some points which are not part of neighborhood of any core point, and thus they are not border points. They are outliers. Like this, we have three outliers, right? So finally, I can answer. I have two clusters having 5 points in each of them, and we have 1, 2, 3 outliers. Two clusters and three outliers. That will be my answer. Now, you can also check in your R programming using the DBSCAN function. Take this X and Y vector and just apply DBSCAN method on it and check whether the class with the epsilon value of 0.6 and mean points of 4, check whether your output of DBSCAN method matches with the output that you have derived just by hand calculation. Thank you.